So I'm looking at the integral of e to the x over 3 plus e to the x. We actually have two different ways that we can solve this. The first is, well, when I first look at an integral, I'm usually thinking, is it just a number times x raised to a power, so that I can use that general power rule for antiderivatives? And this one isn't. I've got e to the x's in there. So my next line of defense in terms of figuring out how to get through an integral really is to be thinking about a u substitution and to ask myself, does the derivative of one part equal the other part? So here, I've made it a little bit more straightforward, but if I look at this denominator, the 3 plus e to the x, if I let u be equal to 3 plus e to the x, then du dx would be e to the x. And in general, we skip writing this step because we already know that we want the differential, not the derivative. But I'll write it out here that I would multiply both sides by dx, so that I'd have du is equal to e to the x dx. So when I go to translate my equation, the e to the x dx gets replaced by du. And that 3 plus e to the x that's in the denominator, well, that's getting replaced with u. Once I've got this down to something I can deal with, I'm looking for whose derivative is equal to 1 over u. And that derivative is going to be natural log absolute value of u plus a constant. Now I'm going to check, was it a definite integral or an indefinite integral? It's an indefinite integral because I do not have bounds on my limits for integration, which means I have to give my answer in terms of x. So I'm going to have ln absolute value 3 plus e to the x plus c. I'll give a second just in case anybody has a question there. I made that one more straightforward, so I'm thinking maybe there won't be questions. Have to put the absolute value. Okay, so I think we talked a little bit about this, gosh, maybe on the first day of co-class. The reason that I have to put the absolute value, or that the absolute value is there for the antiderivative of 1 over u, comes down to the domain. So the domain of 1 over u is that u can take all values except 0, but the domain of ln without the absolute value, it would only take positive values in the domain. So to make the domains match, when we write the antiderivative of 1 over u du, we write it as absolute value. In this particular case, 3 plus e to the x is always positive. So for this particular integral, I don't need the absolute value, but it's better to just leave it there each time. Excellent question on how do you know what to choose for u? And my unfortunate answer to that is it comes with practice. If you have a fraction, in general, you should be thinking about making the denominator your u, but that's also not always the case. It really is going to come down to practice. So let's just do a couple more examples and talk about how do we know what to pick for u. Good. So here I've got a trig function. So I'm trying to find the antiderivative of sine cubed x, cosine x. So here's one where the derivative of sine is cosine and the derivative of cosine is negative sine. So we might be thinking that we could choose either one for u. But I'm going to take another look and say, this piece is a little bit uglier because there's something else happening to that sign. And if I rewrote this to say sine of x cubed cosine x dx, then this piece is a little bit more complicated, and that's the part that I'm going to choose to make equal to u. So if I let u be equal to sine of x, then du is going to be cosine x dx. And this time, I don't have to do anything to it. It's just sitting there. I've got my cosine x dx. That's equal, oops, not dx. That's equal to du. And then sine, we've just, in our vocabulary list over here, we get to swap out sine for u. Find the antiderivative. This one, I've got u to the third, which means I'm going to add 1 to the exponent, divide by the new exponent, add a constant. Then I go back and check, was this definite or indefinite? It's an indefinite integral because I don't have limits of integration. I have to give my answer in terms of x. So in terms of getting the antiderivative from this step to this step, as a general rule, if I'm integrating, like if I have x to the 7th dx, when we take derivatives, we subtract 1 from the exponent. Antiderivatives are going backwards. So instead of subtracting 1 from the exponent, I would add 1 to the exponent. So if I were thinking about my guess for the antiderivative, my guess might be x to the 8th. But if this were the function, and I took the derivative, I'd actually end up with 8x to the 7th, which isn't what we started with. So we correct for that 8 in our guess. By adding 1 to the exponent and then dividing by the new exponent. Now, when I take the derivative and find y prime, I get 8x to the 7th over 8. Those 8s would cancel out, and I'd have the x to the 7th I was looking for. As a general rule, if I have a variable raised to a number in the exponent, when we take the antiderivative, we'll add 1 to the exponent and then divide by the new exponent. In general, we're using the u substitution to simplify the most complicated part, which means the less complicated part should generally get swallowed up in the du. So let's do a couple more examples. Well, if I look at this, it is just algebra, and given time, energy, and sufficient monetary motivation, we could multiply that garbage out, but nobody has time to do that. So instead, I'm looking at this and thinking, does the derivative of one part equal the other part? The other way to think about that is what's the most complicated part of the problem, and that's this piece. Is there a way that I can simplify this piece by making a substitution? So I'm going to start my vocabulary list over here, and that's my target for u. If u is 5 plus x cubed, when I take the derivative, I'll get 3x squared. And again, I'm not really interested in the derivative. What I actually want is the differential. So I'm not going to write that as du over dx. I'm going to write this as du equals 3x squared times dx. Now I'm going to look back in the original problem, and the other parts sitting out here are an x squared and a dx. So I need to match up the x squared and the dx with the x squared and dx over here. That 3 I don't have in the original problem, so I'm going to take care of it in my vocabulary list. So I'm going to divide everything by 3. And now I can take the x squared dx from the original equation and replace it with du over 3. And then this part that was more complicated, once I put the u in, I'll have u to the 7th. You don't have to do this, but I'm going to take that 1 over 3 and move it out in front of my integral. Oops, I switched variables on us. U to the 7th du. I'm going to add 1 to the exponent, divide by the new exponent to get the antiderivative. So I'll have 1/3 u to the 8th divided by 8 plus the constant. And then quick check, it was an indefinite integral. I did not have limits of integration. So my final answer needs to be reported in terms of u. I'm going to go ahead and take that 1/3 and the 1/8 and make that 1 over 24. And there's my final answer.